In this video we're looking at the hyperbola graph, which is seen here. It's a symmetrical graph, and the basic equation for the hyperbola is y equals some constant, we'll call it a, over x. So x is at the bottom of a fraction, or we can rearrange it to x times y equals a. Now, there are parts of the graph that the equation the points get closer and closer, but they don't actually touch the line. The curve here is getting closer and closer, but never touches the asymptote, is what we call it. So the asymptote, it's a strange word with a silent P, asymptote. In this particular graph, it runs along the x-axis and the y-axis. So a feature of this graph, we can say that the asymptote is at x equals 0 and y, this is my y value, is 0, it runs along there. When the x value here is 0, it runs through there. That's our asymptote. And we measure our asymptote, we can find a. So from the centre of the asymptotes, if we look here, we go 1 across and 1 up. Our x is 1, our y is 1. 1 times 1 will give our a. So this is our x times our y times our x. X times y is 1 times 1, which is our value of a. So for this graph, y equals 1 over x. You can also write in your domains of these graphs. They are symmetrical. Our domain, our x values, let's use a blue, our x values go from here to here. So they extend from -5 to 5. So our x is greater than or equal to -5, less than or equal to 5, and x is not equal to 0, and our y value is not equal to 0. There's some features of that hyperbola. Now let's look at our here we have a negative hyperbola. You can see it's in the other quadrants. So this is going to be y equals a over x as our general formula, and we know that our asymptotes again are at x equals 0 and y equals 0. So we can mention our asymptotes. X equals 0, y equals 0. And to come with the formula from our asymptotes, we are -1 times +1. So there's our +1 and -1. -1 times +1 is -1. So y equals a -1 over our x. That's that formula. Our hyperbola has shifted. We can see that it's symmetrical about another line, so let's draw that line in. Our asymptotes, I think, come along here. They get closer and closer to that line. It's easiest to look at the ends, and they still, this is y equals 0. Y equals 0. So this was our y-axis, our x-axis, and y equals 0, and this one here, x, on the x-axis, x is negative 2. X equals negative 2. So we can say our asymptotes are at x equals negative 2 and y equals 0. Our graph never hits those lines. And we have our general formula, y equals a over x, because we know it's a hyperbola. Now it's moved to the left 2. So like our other formulas, moving to the left, we actually have a plus 2 that we can put under here. When it's moved left, it has not moved up or down, and we need to find a. So I'll use, you can see down here in this corner, I've explained here, when our asymptotes have moved from the 0, 0 of the new asymptotes, or the 0, 0, from the centre here, if we go along and up, we have an m and an n. If we multiply those two numbers, we will find what a is. So from our new asymptote here, the blue lines, I go along 3 and up 2. 3 and 2, so 3 times 2 is 6. So a is 6, y equals 6 over x plus 2 is the equation for our parabola. Okay, we're back, sorry. Let's see where our asymptote is here. I think it's through there. And we're still on this axis here. So our asymptote is at, let's look, we've got on x equals, on the x-axis, we're at x equals 0 here. X equals 0 is that one. This one here, it cuts at y equals 3. So those are our asymptotes. We know y equals a over x. Now how far is our, oops, that's not really good. How far is our 0, 0 moved? It's just moved from 0, 0, it's moved up 3. So we have y equals a over x plus 3. Now to find out a, remember we go from the centre of the new asymptote. From here, let's find a point we can go to. We can go along and up, along 2 and up 2. So 2 times 2 is 4. A is 4. Y equals 4 over x plus 3, because it's moved up 3 from 0, 0. Here, let's put our asymptotes in. We've got this one here. And in the middle here, it looks like that one there. So our asymptote is at this point here is x equals negative 3. And we're still on y equals 0 for our other asymptote. And so our equation is y equals a over x. We have moved to the left 3, so it's going to be y equals a over x plus 3. Remember, it goes the opposite way to what you think. To find a, how far have we moved? We've gone, there's a point here, let's see how far to our asymptote, 0, 0. 3 times 2 is 6. So our equation is y equals 6 over x plus 3. And it's symmetrical about the asymptote. We are looking at, I think we just did this one. Did we just do this one? Sorry, I've repeated myself here. Let's check. We've got our asymptote through here. And this was up here at, on our x-axis, x equals -3 is the asymptote, and y equals 0. Our asymptotes, our graph is along 2 and up 3 from the 0, 0, so y equals, that's 2 times 3 is 6 on the top. X has moved 3 to the left, x plus 3 there, and hasn't moved up and down at all. That's that graph. And let's go 7. Okay, we found one more different one. We draw our asymptotes in midway. We're going to look, this is getting closer to here, and these are getting closer to that line there. So our asymptotes, this is our x and our y. Asymptote here is at y equals, asymptotes at y equals -3, and our x is at x equals -3. X equals -3, oops, 3. Those are our asymptotes. Now from y equals a over x. So let's see how far we've moved. X has gone to the left 3. So we have a over x. It's a plus 3 to the left 3. But it's also going down 3. So we're going to do minus 3 there. And our a, how far, find a point that from 0, 0, how far has it moved? Here's probably a point there. Now I don't look at that 5. I've got to see how far from 0, 0 here at the new asymptote. Where has that moved? It's moved 1, 2, 3, 4, 5, 6, 7, 8 across. And 1. 8 times 1 is 8. So a is 8. So our new graph will be y equals 8 over x plus 3, take away 3. And that's our hyperbolas. Thank you.